Welcome to the video lecture on signals and systems. We are discussing about Fourier transform for a while. In this video, we will discuss a few basic signals Fourier transform. So this will serve as a good example on how to perform Fourier transform on any particular signal. First, let's begin with the unit impulse signal. So a unit impulse signal can be defined as x of t is equal to del of t, which is infinity for t equal to 0 and 0 for other places of t not equal to 0. Simply, we can define your del of t signal as integral minus infinity to plus infinity del of t dt is equal to 1. So this is what we are going to use it for finding the Fourier transform of this particular signal. Now, by definition of Fourier transform, x of j omega is nothing but integral minus infinity to plus infinity x of t e power minus j omega t dt. So here let us substitute the x of t. X of t here is nothing but the del of t signal. So integral minus infinity to plus infinity del of t e power minus j omega t dt. So let us use this expression. Del of t dt extends to 1 for t equal to 0. So del of t value we have substituted as 1 for t equal to 0. E power minus j omega t remains the same. So now substituting t equal to 0 in e power, we will get it as e power 0. So 1 into e power 0 is 1, so the value is 1. So Fourier transform of a unit impulse signal is nothing but 1. Next, let us check how to plot the magnitude spectrum and phase spectrum for this unit impulse signal using the Fourier transform. First of all, let me remind you what is the magnitude spectrum. Magnitude spectrum is nothing but square root of real part square plus imaginary part square. And phase is nothing but tan inverse of imaginary part by the real part. So here, as you can see, we do not have an imaginary part. We have only one existing here, which could be accounted for real part. So now, this is nothing but the impulse signal plot, which exists for t equal to 0 and the value may extend up to infinity. Now this shows the magnitude spectrum and phase spectrum of the signal. Now as you can see, I have simply plotted it as 1. Why did I give it as 1? So as I've told you, magnitude spectrum is nothing but square root of real part square plus imaginary part square. We do not have imaginary part here. We have only real part, which is 1. So square root of 1 will be just 1. So the magnitude spectrum is 1 here. Next, let us analyze the Fourier transform of a single-sided exponential signal. A single-sided exponential signal can be defined as x of t is equal to a e power minus at for t greater than or equal to 0. So this means a single-sided signal. This is a causal signal. By definition of Fourier transform, x of j omega is equal to integral minus infinity to plus infinity x of t e power minus j omega t dt. So we will substitute a e power minus at in place of x of t. So we will get 0 to infinity. Why did we give it as 0 to infinity? Because this signal exists only for values of t greater than or equal to 0, which means from 0 to infinity this signal exists. So 0 to infinity a e power minus at e power minus j omega t dt. So whenever you have two e power terms, combine them. So when you combine it, it becomes 0 to infinity integral a e power minus of a plus j omega t dt. Now when you take integral of this part, a is a constant which still remains as a. So integration of e power will yield the same divided by the variable value. So a e power minus of a plus j omega t divided by minus of a plus j omega t. So this has to extend from limit 0 to infinity. Now let us substitute the limit values. Upper limit minus the lower limit. So a e power minus infinity. In place of t, you have to substitute infinity and 0 because we have made this integration with respect to time. So wherever you have t, you will have to substitute the upper limit and the lower limit. So the point is upper limit minus the lower limit. So a e power, you have minus t here. So minus infinity I have substituted. divided by minus of a plus j omega. Upper limit is this part minus lower limit we are substituting. A e power 0 is the lower limit. So a e power 0 by minus of a plus j omega. What is e power 0? 1. And e power minus infinity value is 0. So this term becomes 0. So we will get only this term. Minus into minus will become plus. So the answer is a plus a by a plus j omega. So Fourier transform of a single-sided exponential signal is a by a plus j omega. Now as you can see, this refers to the single-sided exponential signal and this refers to the magnitude spectrum. So magnitude spectrum, as I've told you, it is square root of real part square plus the imaginary part square. So this signal Fourier transform has both real and imaginary parts. So the magnitude spectrum compute as a by root of a square plus omega square. Now how to plot this plot? For fixed value of a, say suppose you can consider a as 0.5 or a as 1. For any fixed value of a, substitute different values of this frequency omega and calculate the magnitude spectrum value. And you could plot this spectrum, this kind of a signal wave, using the values you have obtained by substituting different values of omega.